Good day, students. In this clip, we're going to be going over two examples on how to graph quadratics from standard form using intercepts, roots, and vertices. So for each example, we're going to find the roots first, the intercepts, the coordinates of the vertex, both the x and the y. We're going to describe the opening, the extrema, and find the value of the extrema. We're going to describe the width, and then graph the function. Okay? All right, let's go ahead and take a look at the first problem, question number 1. What if we have the quadratic function f of x equals x squared plus 2x minus 8. Alright, so for the first part, we're going to find the roots of this, or the zeros, and to do that, all we just have to do is write this in standard form, factor and solve. Okay, so set this equal to 0. Make sure it's in standard form. Already is. So let's factor this. If you notice, let's break it down and see if there are any factors first. Okay, so if we break this down into x times x plus 2 times x minus, if you break down 8, you have 2 times 2 times 2. Nothing comes out, so let's reassemble it. X squared plus 2x minus 8 equals 0. Alright, so let's use the x game to factor this. We have 3 times, we want to make it into 4, so we can factor by grouping, okay? So AC goes on top, AC is negative 8, and B is 2, okay? Two numbers that work here are 4 and negative 2, because 4 minus 2 is 2, and 4 times negative 2 is negative 8. Okay, so let's replace the middle term with these two values. So we have x squared plus 4x minus 2x minus 8. Alright, so let's partition it down the center, decompose it, and then factor out the GCF, okay? So from let's decompose everything. We're going to have x times x plus 2 times 2 times x minus 2 times x minus 2 times 2 times 2. Okay? On the left side of the partition, x is common, so we can factor that out. If we factor that out, we'll have x times x plus 2. And on the right side of the partition, negative 2 is common, so we can factor out negative 2 from both sides. So we bring down the negative sign, negative 2. We have to be careful to switch this sign, so we have x plus 4. Okay? Alright, on the left side of my partition, that's supposed to be a plus 4 also, because 2 times 2 is 4. Made a mistake. Okay, so these two quantities match, so this quantity on the left is x minus 4, and this x minus 4 are identical. So factor it out. And then what's left on the outside, we'll put them together in their own parentheses. Set that equal to 0. Okay, now to find the roots, we use the zero product property. X plus 4 equals 0, and x minus 2 equals 0. Okay, for the first one, we'll subtract 4 from both sides. And then we have x equals negative 4. And then on the right, this second root here, we add 2 to both sides, and then you have x equals 2. Alright, so there goes, these are your roots for the equation, okay? Alright, now roots, x equals negative 4 and 2. Now what we're going to look for next are the x and y intercepts. So let's put that over here, B. The x-intercepts are simply your roots, okay? So your x-intercepts are going to be negative 4 and 2. Your y-intercept is going to be the value of c in the standard form of the equation of your quadratic function, okay? So the c is negative 8, as you can see here, negative 8, so your y-intercept is negative 8. And next we're going to find the vertex. Alright, so to find the vertex, To do that, we'll start with the x-coordinate of the vertex. For that, we're going to use the formula negative b over 2a. Okay? So in this problem, we know that b is 2 and a is 1. From this equation right here, you can see a, b, c. So if we input that in here, we'll have negative 2 over 2 times 1. Okay? This simplifies into negative 2 over 2, which is negative 1. So there goes the x-coordinate of your vertex. Now the y-coordinate of your vertex is what you do when you evaluate the function as the x-coordinate of your vertex. So f of negative b over 2a. We already know that negative b over 2 is negative 1, so we're going to evaluate f of negative 1. Okay? So what does f of negative 1 mean? It simply means for this function, the original function, we're going to plug in negative 1 for every x that we have. Alright, so it's going to become negative 1 squared plus 2 times negative 1 minus 8. Now we're going to use the order of operations to simplify this expression. So we have 1 minus 2 minus 8. This comes out to negative 9. Okay? Now that we have the x-coordinate of our vertex and the y-coordinate of our vertex, the coordinate of the vertex is going to simply be the combination of the two, negative 1 for the x and negative 9 for the y. Alright? So that goes your vertex. Alright, now let's describe the opening, extrema, and the value, part D. So let's start with the opening. Alright, so since a is greater than 0 or positive, the parabola opens up. We're gonna have a happy situation right here. So since a is positive greater than 0, the parabola opens up. Parabola opens up. Okay, and then the extremum value, since it opens up, the extrema is gonna be a low point, which is a minimum, right? So we're gonna have a minimum, and the value is gonna be the y-coordinate of your vertex, which is negative 9. Y equals negative 9. Okay, so that's the minimum value. All right, now let's describe the width and the e part. So the width, since the absolute value of a is equal to 1, is going to be the same size. Okay? Same size as what? As your parent quadratic y equals x squared. Alright, let's go ahead and graph the function using all this information that we have. Okay? So we know that, let's look at our intercept is negative 9, and our vertex is now y-intercept is negative 8. Yeah, y-intercept is negative 8 and our vertex is negative 1, negative 9. Alright, so we have to make it sufficiently low so that we can compensate for that. So let's draw our y-axis, and then make our x-axis a little bit higher. Okay, so our roots were 2 and negative 4. So we have, let's go by 2's 1, 2 to the right, and then 1, 2, 3, 4 to the left. So this is negative 4, and this is 2. And then our y-intercept is 1, 2, 3, 4, 5, 6, 7, 8, negative 8. And our vertex is negative 1. This is negative 1 right here, negative 1, negative 9. Alright, so let's graph the points. So we have, this is our vertex, this is our y-intercept, this is our first root or 0, and then this is our next root or 0. Alright, so we can go ahead and sketch the parabola through these points. Something like this, and then the other one goes like this. Alright, so we're going to be expected to label this completely. label this fully. So let's go ahead and label the graph. All right, so this one right here, we're going to call it the first root, R1. Actually, root 2, which is 2. And then this point right here is going to be the first root, root 1, which is -4. This is our y-intercept, which is -8. This is our vertex, which is -1, -9. And if we trace our vertex to the x-axis, that value right here, that value is your minimum. Okay, so it's your minimum, and it has a value of y equals -9. And don't forget your axis of symmetry right down through the center. This right here is your axis of symmetry. Let's label that axis of symmetry. And the equation of the axis of symmetry is x equals the x-coordinate of your vertex, which is -1. Alright, so there you have it. Alright, let's take a look at another example. Number 2, what if we have the quadratic function f of x equals x squared minus 4. Okay, we're going to do exactly the same procedure. So for the a part, we want to find the roots of the function or zeros of the related quadratic equation. Let's find that first. So to do that, we're going to set the function equal to 0. So let's factor this. This is a difference of squares, so we can just factor this using a shortcut. We root the first and the last, and we add and subtract the square root. Okay, so that gives us x minus 2 times x plus 2 equals 0. Okay, now we just set both factors to 0 using the zero product property, and that tells us what the roots are, so we can add 2 to both sides. The first root is x equals 2, and then the second part you subtract 2 from both sides, and the second root is x equals -2. Okay, so our roots are x equals 2, -2, and 2. Okay, all right, let's find the intercepts. So the b part, intercepts. The x-intercept are basically your roots. So you already know what they are. Your x-intercepts are -2 and 2. Your y-intercept is the value of c, and as we can see here, c is -4. So y equals -4 is your y-intercept. All right, next thing we need is the coordinates of our vertex. Okay, and then we can go ahead and write down what the vertex is. So for part C, we need the vertex. All right, so to find the x-coordinates of our vertex, we're going to use -b over 2a. In this problem, a is 1 and b is 0. Notice there's no value with x behind it because b is 0. So if we plug that in here, we're going to have -0 over 2 times 1, which is 0 over 2, which is 0. Okay? And then the y-coordinate of a vertex is what we get when we evaluate the function at -b over 2a. Okay? So we know -b over 2a is 0, so we're going to basically look for f of 0. What does f of 0 mean? It basically means that we're going to plug in 0 into the x's in the function. So we have 0 squared minus 4 equals -4. So there goes the x-coordinate of your vertex. So our vertex is going to be the combination of these two, 0 and -4. Okay? All right, next thing we need is we're going to describe the opening, extremum value. So the opening, we know that a is positive, is greater than 0, or positive. So what does that tell us about the parabola? It opens up because we have a happy situation. The parabola looks something like this. It opens up. Okay? So the extrema and value since it opens up, we know that the extrema is going to be a low point. Okay? So the low point is known as the minimum, and the value is the y-coordinate of your vertex, which is -4. So y equals -4 is your minimum. All right, next thing we need is a width. So the width depends on the magnitude of A. So the absolute value of A is equal to 1. It's going to be same size as your parent quadratic y equals x squared. Okay? So now we have enough information to generate a graph of the function. So let's look at what we have. The y-intercept is -4, so it goes down a little. And our x-intercepts are basically symmetric relative to the y-axis. So we're going to make our y-axis exaggerated in the southward direction or in downward direction. That means that we'll elevate our x-axis higher. Okay? Alright, so there goes your y and your x-axis. Labeling the x-axis, x, y. Let's call this 1, 2, +2, and then 1, 2, -2. Alright, and then our y-intercept is going to be going down. Our y-intercept is -4, so we're going to go 1, 2, 3, 4. Okay, let's go ahead and label the components. Our y-intercept is -4, and that also happens to be our vertex. And these are the zeros of the related quadratic equation or the roots of the function. Okay, so there you have it. So let's go ahead and graph the parabola through these points. Right there, something like that. And then the next one there, like that. Okay, and let's go ahead and label it. This is a second root, root 2, which is x equals 2. And then this is root 1, which is x equals -2. And this right here, this is your vertex. Our vertex is 0, -4. And is also your y-intercept. Okay, and guess what? This is your minimum value too. So your minimum value is y equals -4. And as there wasn't enough, there also is your axis of symmetry lies on that same line because the vertex falls on the y-axis. Okay, so this line is also your axis of symmetry. Axis of symmetry. Remember, the equation is going to be an x-line, right? Axis of symmetry, which is x equals the x-coordinate of your vertex, 0. Alright, so there goes the completely labeled quadratic function using the roots, intercepts, and vertex. Alright, so there you have it. Alright, so how well have you mastered this whole process? Well, I'd like you to try the following examples. So try these, and in the comment section below you can post what the results you got were. So try these. Number 3. How about we have the quadratic function f of x equals x squared minus 16. Okay, and then for number 4, f of x equals x squared plus 2x minus 24. Alright, so go ahead and find the relevant components, although it'll be almost impossible to post a sketch, but just find the relevant components of this, the intercepts, the roots, the vertices, the opening, and post in the comment section below. Let me know see if you really mastered this whole process, okay? Thanks so much for taking the time to watch this presentation. You can feel free to subscribe to my channel. To subscribe to my channel by clicking up here. More clips can be found on mathgotserved.com. Thanks again for watching and have a wonderful day.